Right, let's take a look at these past paper questions then. So Mr. and Mrs. Khan are beginning to think about their holiday plans for next year. So far, they've decided that the holiday will be in May or in September. It will be in the UK or in Ireland. It will be a single location or a touring holiday. Complete the table below to show all the possible combinations that they might finally choose. One of the possible combinations has been given to you. Okay, so they've laid this out on the table. It's giving you a real big hint what you're supposed to do here. It's just like that example with the Thai menu that we looked at. So remember what I said, fix one variable or two variables and then alter the other. So we've got here that it could be taken in May in the UK at a single location. I can fix May and the UK, and it could be a touring holiday. So I've got May UK single, May UK touring. What else could we do in May? Well, we could go to Ireland. So in May, fixing that one, that could be Ireland and single, or in May they could go to Ireland and tour. That's it as far as May is concerned. So now we move from May to September. In September we'll fix the UK and a single, or in September in the UK they could tour. The other choices in September are they go to Ireland and single, or they go to Ireland and tour. And that's it. There are no other combinations that they can do, and because we've been systematic, we know we've got every possible outcome there. So that is it. 3 marks. Question 2. A fair coin and a fair 6-sided dice are thrown together. Calculate the probability of obtaining a head and a 2. So I've got two things that are happening. I've got a fair coin, and possibly out of that I could get a head or a tail. And then I've got a fair 6-sided dice, which is going to give me a 1, 2, 3, 4, 5 or a 6. So in order to determine the probability of getting a head and a 2, I need to list all my possible outcomes. So I could have a head and a 1. I could have a head and a 2, a head and a 3, a head and a 4, a head and a 5, a head and a 6. There's nothing else I can get with a head. Once I've exhausted that, I then go to tails. And I go to tail 1, tail 2, tail 3, tail 4, tail 5, or tail 6. Nothing else I can do. So those are all the possible outcomes. I want the probability of a head and a 2. Well, there's only one way you're going to get a head and a 2, which is that one, out of the total number of possible outcomes, 2, 4, 6, 8, 10, 12. So the probability of getting a head and a 2 is 1 out of 12. Question 3. Pupils have a choice of a sandwich and a drink for lunch on a school trip. They can choose a ham, a cheese or a salad sandwich, and to drink they can choose water, milk or orange juice. Write down all the possible combinations of sandwich and the drink that the pupil may have for lunch on the school trip. So this is the same as the Thai menu question or the one we just did on holidays. So we can have ham. With a ham sandwich, my choice of drink is ham and water, or it's ham and milk, or it's ham and orange juice. As far as a ham sandwich is concerned, that's it. We could have a cheese sandwich with water, a cheese sandwich with milk, a cheese sandwich with orange juice. That's it for cheese. Or we could have a salad sandwich with water, a salad with milk, or a salad with orange juice. So have I done everything? Write down all the possible combinations of a sandwich and a drink that a pupil may have for lunch on a school trip. 3 marks. 3 easy marks. Question 4. Nia has made up a game using 2 fair spinners. The faces of the spinners are shown below. So I've got a triangle spinner which has got the numbers 1, 3 and 5 on, and a square spinner with 2, 4, 6, 8. The first spinner is an equilateral triangle with sections numbered 1, 3 and 5. The second spinner is a square with the sections numbered 2, 4, 6 and 8. Nia spins the triangular spinner first, and then she spins the square spinner. So she's spinning that, spinning that. Her score is a 2-digit number. The first digit is the number on the triangular spinner, and the second digit is the number on the square spinner. So the number that we're looking at there is 32. Nia writes down all the possible scores she could obtain. Some are done for you. Complete the list of all the possible 2-digit numbers she could get. So she's fixed 1, and then put the 2, 1, 4, 1, 6, 1, 8. So the next pair or set would be 3 fixed. So you'd have 3, 2, 3, 4, 3, 6, 3, 8. And then if the first spinner landed on 5, you'd have 5, 2, 5, 4, 5, 6, 5, 8. Those are the only set of numbers that you could get out of those 2 spinners. B part 1. Write down the probability that Nia gets a score that is greater than 37. So I want to look at my possible outcomes. So the probability the score is greater than 37 is going to be 1, 2, 3, 4, 5. There are 5 numbers there that are bigger than 37. Out of, remember to count the ones that are printed. A common mistake with questions like this is students forget to count and include the ones that the question gave you. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the probability that Nia gets a score greater than 37 is 5 out of 12. Write the probability that Nia gets a score less than 70. Well, all the numbers are less than 70, so it's certain. So you can either write that as, so probability score less than 70. It's certain, so it's 1. Or you could write it as 12 out of 12. Nia says that she will always get even numbers for her results. Is she correct? You must give a reason for your answer. Well, we can see from our list that all the numbers are even, and the reason for that is the numbers on the square spinner are all evens, and the numbers on the square spinner give you the units number. So yes, she is correct because all the numbers on the square spinner are even. So there you go, that gives you that mark. Question 5. 2 spinners are spun. The score is the total of the 2 numbers shown on the spinners. The score shown above is 8. So you've got a 5 and a 3 makes 8. There are 2 different game cards, card A and card B. The game is played crossing out the scores from the spinners on the game card as the spinners are spun repeatedly. The first game card with all 4 scores crossed out is the winning card. First game card with all 4 scores crossed out is the winning card. Okay, so we've got these 2 cards. So that's got a total of 8. 8 wouldn't cross out anything on either card. So what we need to do to answer the question, which game card is more likely to be the winning card, you must show your working and give a reason for your answer. Okay, so the first thing we need to do is work out what all the possible scores are for those 2 counters. So if we call that spinner 1 and that's spinner 2, then the possible scores you could have a 1 on spinner 1, fix that, and then we could get a 1, and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5. Two, 3, 4, 5, 6. Or we could get a 2 on spinner. So we get a 2 on spinner 1, and then a 1, a 2, a 3, a 4, or a 5. 1, 2, 3, 4, 5. And we add those together. We get 3, 4, 5, 6, 7. And then we could do the same for 3 and 4. Probably a better way of doing this one actually is as a sample space diagram. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We could carry on with that, but that's just going to run out of space. So that's spinner 1. This one's spinner 2. And we're going to add the scores together. So we could have 1 and 1 is 2, 3, 4, 5, 6. 3, 4, 5, 6, 7. Yeah, so 4 and 2 is 6, 5 and 2 is 7, and so on. 3 and 1 is 4, 3 and 2 is 5, 6, 7, 8. And then we've got 5, 6, 7, 8, 9, 6, 7, 8, 9, 10. So all the possible scores are there. So I've got 25 possible scores. Now, game card A, to win game card A, you need to have a 3, and a 2, and a 9, and a 10. So the 3 has got 2 different ways of getting that. The 2, there's only one way. The 9, there are 2 ways. And the 10, there's only one way. Whereas for game card B, to get the 4, you've got 1, 2, 3 chances. To get the 6, you've got 1, 2, 3, 4, 5 chances. To get the 5, you've got 1, 2, 3, 4 chances. And to get the 7, you've got 1, 2, 3, 4 chances. So the numbers on game card B come up much more frequently than the numbers on game card A. So it's going to be much easier for game card B to win. So which game card is more likely to be the winning card? Card B is more likely to win because the winning numbers come up much more frequently than on game card A, or more often. On card B come up more frequently than the scores on card A. So you want to be putting that into your own language. You could just say that these numbers occur more often, anything like that. But the important thing is that you spot it's a spinner, so I need to work out all the possible scores. Okay, whether you do it as a sample space or like that. I changed my mind halfway through, which you probably wouldn't have done, but it's just quicker to have done it that way. So those are the past paper questions on listing possible outcomes.